Hello everyone, this is Shaunak from FMCG, your AIML consultant. In this particular notebook, we will be focusing on Seaborn, the second data visualization library after Matplotlib that will be focusing. So Seaborn is a data visualization library. It is built on top of Matplotlib, and Seaborn provides quite a bit of graphs and plots and a lot better aesthetics than Matplotlib. So let's dive in. So in this notebook we'll be focusing on 12 plots or charts. So if you see over here, first one is pair plot, this one, then line plot, third one is disk plot. Disk plot is similar to histogram, so it gives distribution of the frequencies, and fourth one is joint plot. So if you see over here in the graph, we are getting Kde plot as well as scatter plot. Then fifth one is Kde plot. So Kde plot is similar to frequency distribution plot. Then scatter plot, again scatter chart. Then seventh is bar plot. 8 is cluster map. Cluster map is similar to heat map, but we also get hierarchy when we plot a cluster map. Then ninth one is box plot. 10th one is violin plot. 11 is regression plot. Regression plot is basically you draw the regression line and you also plot the points. So for if you have worked on classification problem and regression problems in machine learning, so for regression prediction, so you plot the regression line, which is the line of best fit, where the overall loss is the least, so that you can plot regression plot. And last one will be the heat map. So let's start. The libraries that I'll be importing is, so ignore the second and third line because this code is used to ignore the warnings that we'll be getting. Then from fifth point onwards, I have imported pandas, then Matplotlib, then Seaborn, and then NumPy. Matplotlib is for accessing the data frame, reading our CSV file, and for any change in our data frame that we want, we can do it via pandas. And NumPy is for getting us numeric pandas. So if you want to perform any complex numerical operations, we can do it using NumPy. For that purpose, I have imported NumPy. And the dataset, similar to the previous video, if you are following the series chronologically, so in the previous video regarding Matplotlib, we have used the same dataset of FIFA 22 players, and in that particular dataset we are focusing mainly on the players who are playing for Manchester United. So if you want to see the data frame, sorry, I have yet to import the libraries, and then we'll import the dataset. If you want to see the list of columns, these are the names of the columns: player URL, short name, long name, player position, overall, potential, value, euro, wage, euro. I'll just show you how our data frame looks so you get a rough idea. By the way, the data frame that we are going to use is of Manchester United, so that has, I guess, 33 rows and 110 columns. Let me just quickly show you. Yes, 33 rows and 110 columns. And I'll show you the first 5 rows. So if you see, this is the ID, player URL, short name, long name, then player positions, overall. So the things we'll be focusing on will be overall, potential, so basically the numeric values, then value in euro, wage in euro, age. Moving ahead, so the first plot we'll be focusing on is pair plot, this one. So we can plot many numeric features on pair plot. So it is similar to correlation, but not correlation, but we will be plotting every column against another column. So for demonstration purpose, the columns that we will be focusing on will be overall, potential, value in euro, wage in euro, age, And preferred foot is not a numerical column. Preferred foot is a nominal column because preferred foot values are either right or left. So we'll be using that to draw the u as in we'll be getting one graph for left foot, one graph for right foot, and those will overlap each other. So I'll remove this since we are going to write every code from start to end. So I'll tell you a simple skeleton. So first I'll show you the skeleton and then we will draw the pair plot. So you start with plt dot figure, exactly similar to what you did in matplotlib. So since Seaborn is built on top of matplotlib, this code remains the same. And here fixed size, let's say we plot 6 by 6, and then on next line I'll keep it blank because we are going to enter the Seaborn code over there. And after that we'll give title, plt dot title, let's say we give it as pair plot for different FIFA attributes. Then plt dot x label calls and plt dot y label. Here I'll write y calls and here I'll write x calls. And then plt dot legend and plt dot show. So this is the basic skeleton. And on the second line, that is here, I'll be typing in the Seaborn code, which is we have imported Seaborn as SNS. So SNS dot pair plot, and here I have to pass in array. So our parent data frame is mufc underscore df, and here I'll pass in the list. So list is pair plot list. And then here I can mention the kind of graphs that we want. So let's say the kind of graph we want are scatter, and we can also determine the kind of graph we want on our diagonal. So diag, diagonal kind, if we say kde, kernel density. So and u, if we give it u as preferred foot, which is a nominal column. And now if we execute, it is taking time but it will execute. So if you see over here, we are getting every column plotted against another, and it is quite big. So let me just reduce 3 by 3. It should appear a little smaller now. 1 2 3 4 5. Yeah, so for 5 numerical columns it is plotting the graph. And if you want, you can change the kind as KDE as well, so it will give contours for left foot and right foot. So if you see the legend over here, orange or yellow occur, the color scheme, left is shown in orange and right is shown in blue. So you can see it over here, and this is the KDE kernel density. So along the diagonal it is KDE, and along non-diagonal it is again KDE, but it is in contour format. So you can change it to scatter if you want, scatter plot. There we go. So now we have scatter plot for it. So this is how you plot pair plot. So if you see, we have used overall, potential value, euro, wedge, euro and edge. So overall is plotted against potential value, euro, wedge, euro, edge. Similarly, every other numerical value is plotted against another numerical value. So if you see, overall plotted against, this one is potential, this column is value euro, this column is wedge euro, and this one is edge. So everyone is plotted against each other. So that's all for pair plot. Moving on to the next plot, it is line plot. So if you see over here, the code that remains the same. First one is plt.figure, second one is the code for Seaborn, third one is title, then label on x-axis, y-axis. X-ticks, the usage of x-ticks is to basically tilt the labels on x-axis. For that purpose this rotation is used. By default, the annotations which are appearing on x-axis, those will appear at an angle of 0 degree, so totally horizontal. But if you want to tilt them, you can give this rotation. And legend is to give this legend visibility, so that's the reason legend is mentioned. And plt.show is to show the graph. So let us plot it. So plt.figure fixed size. So since it is a line plot, so let us plot 10 and 4, and sns dot line plot, data is our MUFC, and x equal to, so in this particular example we are going to plot age versus overall. So x. Also one more thing, the parameters on x-axis, the column that we are going to plot along x-axis, that needs to be in ordinal format. So we have to first sort the data frame along, since we are going to plot age on x-axis, we will sort our data frame as per age. So first I'll show you what happens if we do not sort the graph as per age, and after that I will sort the graph as per age, and then we will plot it. So here age, and then y equal to overall, and we will plot two line graphs, one for players who are using their preferred foot as right, and another one for left. So u equal to preferred foot, plt dot title. So let's give title as age versus overall, and then plt dot x label. On x-axis we have age, and plt dot y label we have overall, plt dot show. So it is appearing, I guess age is already sorted, so that's the reason it is appearing in incremental format. So it is appearing properly. So blue is for right-footed players. If you see, as their age is increasing, their overall is also increasing, and it has spiked above 35 a little. That is because of only one player who is aged above 35 and his overall is above 90, in the Cristiano Ronaldo case. And this is for left-footed player, the yellow one. And if you want to see how to sort it, I'll show you how to sort it. So let's say line df equal to MUFC dot sort values by age, and that we are going to save in this line df. It should not be any different, it should appear as it is. Yeah, so it is appearing as it is. So that's all for line plot. Code block. Moving on to the next plot, histogram. So histogram is basically, it gives distribution of frequency. So let us plot the skeleton, plt.figure fixed size. Again let's plot it as 12 as width and 4 as height. The first parameter is the width and the second is the height. And sns dot dist plot, and here we have to pass in the array. So let's say we want to plot the graph of overall. So MUFC df dot overall. So this gives us panda series, which is a 1D array. And right now I will not define the number of bins. I'll tell you what the bins are in just in the next 1 minute. So plt dot title this plot of overall, this will be the title. Plt dot x level measurement, then plt dot y level, let's give it as count. So these names that I am writing over here in string, so this can be anything, that is totally, you can give it any name that you want, which you feel fit. And plt dot show. So this is the distribution plot, dist plot. And if you right now 1 2 3 4 5 6 7, we are getting 7 bins. If you want to increase the number of bins, you pass in the bins parameter in SNS. So bins equal to, let's say 33, because we have in total 33 players registered for Manchester United, that is 33 rows in our MUFCDF. So bins 33, it is giving me a detailed version of the bars in our histogram. So that's how you can increase the number of bins, and you can decrease as well. If you want less, instead of 33 you want 20, you can do that as well. Now moving on to joint plot. So joint plot, if you see at the top, so this is how joint plot appears. So we'll be plotting the joint plot now. So I'll just remove this since we're not going to use it. Okay, so skeleton plt dot figure fix size, and let's draw it as 6 by 6, height 6, width 6. Then SNS dot joint plot, here data equal to MUFCDF, and on x-axis, so on x-axis, let's say we'll, in this example we'll plot age versus overall. So on x-axis we will plot age, and on y-axis we will plot overall. And the hue, that is the color, we will differentiate based upon the color for prefer foot. So we will get plot for people playing with their right foot and people playing with their left foot. So hue as preferred foot, then plt dot title joint plot for age versus overall, and I'll just make this A capital so the consistency is maintained. Plt dot x level, it will be on x-axis we have taken age, and plt dot y level, on y-axis we have taken overall. Plt dot legend, and then plt dot show. And we are getting a 6 by 6 size of joint plot for age versus overall. And on x-axis we have age, and on y-axis we have overall. So here it is scatter plot, and on the x and y-axis, if you see, we are also getting a KDE plot, that is a distribution plot. Blue is for the right-footed players, and orange is for the left-footed players. So that's all for joint plot. Now moving on to the next one, KDE. So the code exactly is similar to the above one, just instead of joint plot you have to use KDE plot. So above, as in the code is similar to the dist plot, that is the histogram, because for KDE plot you have to pass in 1D array. So let's do it. Plt dot figure fix size, let's say 10 by 4, and then SNS dot KDE plot, and the 1D array that will be passing MUFC dot, let us plot for overall. plt dot title kde plot for overall, plt dot x level, it will be overall, and plt dot y level, it will be count, that is the number of players, and plt dot show. So we have received this kde plot for overall. So the peak maximum number of players are having their overall just above 80. And if you let us check this particular aspect as well in kde. So either you have to use this 1D array or you can use this my bad, sorry. Excuse me. Now we can also add u. In u we can pass in preferred foot, which is a nominal value, either left or right, and then multiple, so it can either be fill or stack, and alpha that will give is, let's say, 0.5. okay, so here we have to pass in data as MUFC and x as overall. Yeah, so this is how it will appear if you pass in the multiple as fill, and if you pass it as stack, it will appear differently, stacked one above the other. Blue is for right and this orange is for left. So we saw plotting this particular kde plot without u, that is for all the players, and if you want to separate it as per preferred foot, you can do that as well by passing u as preferred foot, and you can either set multiple as fill or stack. And alpha is how dark these colors appear. If you increase the value of alpha, the colors will grow darker. If you decrease it, the colors will go lighter. Code block, I'll just delete this because we have already executed this above. Now moving on to sixth one, scatter plot. So scatter plot, we have already plotted one scatter plot here in joint plot. So just the center part of this is the scatter plot. If you see over here, this one, plotting two numerical values against each other. Format remains the same, just the change is in this second line, sns.scatterplot. This one, x is the first numeric column, y is the second numeric column, and again you can differentiate as per based upon the color. If you have a nominal column in it, and in our data set we have the nominal column, which is the preferred foot, left footed player and right footed player, and you can also change the size as well. So what we will do, we will plot a scatter plot of age versus overall, and the u, that is the color, will be based upon left footed player and right footed player, and the size of these dots that will be appearing will be dictated by the wage that they are earning. So if someone earns a big amount of money, then their spot will be bigger in diameter, and if someone is earning less, then their spot will be smaller. So plt dot figure fix size, let's say 6 by 6, and then sns dot scatter plot, and data will be MUFC. X on x-axis we are plotting age, on y-axis we are plotting overall, and u will be as per preferred foot, and size will be as per wage earned in euros. Then plt dot title scatter plot of age versus overall, plt dot x level, we will on x-axis we have age, we'll just copy it for the essence of time. And on Y label we have overall, and plt dot legend plt dot show. This will give us a good scatter plot. And if you see, this is bigger in size compared to these spots. This is the biggest, I guess, because it is above 90 and age also above 35. This must be referring to Cristiano Ronaldo. And if you see the size, it is shown in the legend, the size comparison, and also the color: blue for right, orange for left. You can change the location of this legend. You just have to put in pass in a parameter called lock in the legend. So if you say 1, it will appear in the top right. If you say 2, it will appear on the left side. So by default it goes to the best fit position. If you say 7, it is appearing on the right. 9, it is appearing at the center in top. So I guess the first one was appearing properly as per best fit, so I'll keep it at that. So that's all for scatter plot. I put this code block in many cells, so I'll just remove it. Also, by the way, if you want to practice yourself, I'll also be uploading a blank notebook with the instructions, so you can solve. If you want to practice, you can practice in that blank notebook referring to the instructions if you want. It is uploaded on GitHub. Now coming on to the next one, bar plot. So if you refer to the second line again, you have to say sns dot bar plot. Data is our data frame MUFC df, and on x-axis we have nominal columns, that is non-numeric, and on y-axis we have numeric column. And for example purpose, will be on x-axis will be having players belonging to particular countries, and on y-axis we will be having their overalls, and u as in the color will be as per their preferred foot, whether either left footed or right footed. So plt dot figure, fixed size, so let's plot 10 as the width and 5 as the height. Then sns dot bar plot, and our data frame is MUFC underscore df, and on x-axis we will be having nationality. I have got the spelling wrong, so this is the correct spelling: nationality name. And on y-axis we have overall, and the color u will define the preferred foot. Then again plt dot title bar plot for nationality versus overall. Then plt dot x label, nationality. Plt dot y label, on y-axis we have overall. Plt dot show. So if you see, we have the values for different countries based upon let me just increase the width. Yeah, so now it is appearing even better. If you want to tilt the names, we can tilt the names as well by passing xticks, plt dot xticks, and the parameter I'll be passing is rotation equal to 60. So let's tilt it by 60 degrees. So if you see, the names of these countries are being tilted by 60 degree. So in some cases the orange one is not appearing, because if you refer the legend over here, blue means right footed and left means blue means right footed and orange means left footed. So if you refer for Portugal, since only blue is appearing, that means because none of their players, means those who are playing for Portugal, have a left footed player. And for Spain, if you see, there are both blue and orange. So people who are coming from Spain to play for Manchester United, so some players play with right foot and some play with their left foot. But the overall of players playing for playing using their right foot is greater in this case compared to that of left foot. Then moving on to the next one, cluster map. So what is a cluster map? So if you see here, if you see point number 8, so this is the cluster map. It is similar to a heat map, but it also gives the hierarchy. So let us focus on the cluster map. For that, the data set that we'll be using, the cluster map data set, we'll be focusing on these these 5 numeric columns: overall potential, value in euros, wage in euros, and age. And this is the data frame for cluster map. If you want, I can show you the data frame. It will have 5 columns: overall potential, value, wage in euros, and age. So in the code block, plt dot figure fig size, let's say 6 by 6, then sns dot cluster map data equal to this cluster map df, and on x-axis, or let us find the correlation. Yeah, so if you see over here SMS cluster, you have to pass in the data frame. We'll pass in the correlation frame because these values are not normalized, so it will not appear properly. Rest of the stuff remains the same. plt dot title, let's give it scatter plot of numeric values, plt dot show. So if you see, it is giving us a cluster map. These things show the hierarchy. So if you see, age, potential, value, euro, overall wage, age, potential, value, overall wage. So our actual sequence was overall potential, value, wage, and age. But while the cluster map is plotting the map, it is sorting the columns as per its hierarchy. And this is the color scale, and referring to this color scale, we can tell the value. Light means it is approaching 1, and black means it is approaching minus 0.25. Next one, box plot. So basically, box plots are used to find the median interquartile range, and if you want to plot, if you want to see whether there are outliers in your numeric data, for that reason we plot box plot. Sorry, twist my tongue over there. So let's plot it. For this example, we'll be checking overall, the box plot for overall, whether there are any outliers in overall. For first demonstration, I'll not be considering nominal column, but I'll also then show you the same by using the nominal column. So plt dot figure fig size 5 by 5, then sns dot box plot, then data equal to mufc df, and on y we have overall. Right now I will not consider the nominal column, which is our preferred foot. First I'll show you how just overall appears, and then I'll show you how we can plot based upon the difference nominal values. plt.title overall box plot, plt.xLevel overall, plt.yLevel values, and then plt.show. So this is the box plot. So if you see, two values are outliers in the lower range, and this horizontal bar and this horizontal bar, the values appearing in this. So this is the interquartile range. This is the maximum, this is the minimum, and these two are the outliers. This is the median value, and this is our interquartile range. Let me just quickly show you box plot annotations for IQR and median. Let us see whether we have So if you see, this is the minimum, this is the maximum, and this part is the interquartile range, and the demarcation in the at the middle is the median. So this is the median, this is the interquartile range, and this is the max, this is the minimum, and these two are the outliers. Now this is for the entirety of our data for overalls. But what if you want to split as per the nominal column of preferred foot? If you want a different box plot for left-footed player and right-footed player, you can do that as well. So you just have to pass in X as preferred foot. So now if you see, you are getting 2, and let me just quickly pass in the legend, plt.legend. So okay, so legend is not appearing, so because right and left values are appearing over here. So this one is for right-footed players and this one is for left-footed players. So the outlier that we were seeing, that is reduced to 1, which was for left-footed player, so it is appearing over here. So that's how you can use nominal values to plot. In our example, we are able to plot two box plot, for one for left-footed players and one for right-footed players. So depending upon the values present in the nominal column, you will get that many box plots. Now on the next one, violin plot. So the code remains exactly the same compared to this. So let me just copy this and paste it just to show you how easy it is. And instead of box plot, type violin plot. Legends is not required. And same, we are getting the violin plot, and just instead of overall box plot, it should be violin plot. Same, right and left, we are getting violin, and this increase in the width, so that tells the increase in the frequency for that particular value. So for right-footed player, maximum count is in the range of 80, and same goes for left-footed player. And you can also draw this, these are vertical, you can also draw these as horizontal as well. So if you see, these are the available parameters which you can pass: order, U order, BW, cut, scale, grid size, width, inner box, split. So if you pass in inner as box, it will also show a box, inner as box. Why it is not showing system data? Let us check. Okay, so inner as box, it is by default it is showing as box. Then yeah, inner box, quartile, point, or stick. So by default it is showing box. Let us check for quartile, how it appears if we use quartile. Yeah, so it is, instead of box, it is showing as quartile interquartile ranges. So that's all for while in plot. This is the code block. Now regression plot, that is reg plot, it draws the line of best fit. So dataset, so I have created a small subset of our dataset of overall, sorted overall. So it is sorted as per overall. So starting from the least overall, it will go on increasing to the maximum overall. Let me just remove this. Yeah. So we will plot age versus overall, regression plot. So plt dot title, instead of title, let's start step by step. Plt dot figure, fix size 10 by 4, then plt dot not plt, sns dot reg plot data equal to mufc overall sorted, and on x-axis we will take age. Okay, no, we have sorted as per overall, so on x-axis we will take overall, because the ordinal value, that is a sorted value, should be on the x-axis, and on y we will take age, and then plt dot title reg plot overall versus age, then plt dot x level. On x-axis we have overall, on y-axis we have age, and plt dot show. So this is the graph. So as we see, as overall increases, age also increases, and this is the line of best fit. And if we add hue, we can also change the color hue as per preferred foot. Okay, so we cannot pass the hue parameter in this particular case, so that's the reason it gave me the error. It was for scatter plot, this is for regression plot. So one dimensional array of overall and one dimensional array of age, so we are plotting them against each other. So that's for regression plot. Last one is the heat map. So heat map is similar to this cluster map, just that in cluster map the columns, they get rearranged as per the hierarchy. In heat map it does not get rearranged. So for heat map I have prepared again this a subset of our data frame, which consists of these 5 numeric columns: overall, potential, value, euro. If you want, I can show you the heat map data frame. Not show, it is head. That show was for PySpark. So ignore what I said about PySpark. I don't want to confuse anyone. So the head, that is the first 5 rows. This is how our data frame appears: overall, potential, value, euro. And now let us plot heat map. Plt dot figure, fix size, let us plot by 5 by 5. Then sns dot heat map, we will plot for correlation, so it remains normalized. So heat map df dot core. If you are wondering what correlation means, so here is the heat map, and if I pass in the core, so it is giving the correlation of every column against the other column. So overall itself will always give 1, so diagonal elements will always show 1. The values range from -1 to +1. -1 means strong inverse correlation, +1 means strong direct correlation, and if it is 0, then it says there is no correlation. So here I am passing in heatmap.core, then plt.title, heat map of numeric attributes, and plt.show. So this is the heat map that we have received, and if you see overall potential, value euro, wage euro, age. So the form, that is the sequence of this list, is maintained over here, but when we were plotting this cluster map, the sequence was not maintained because it rearranged the columns as per the hierarchy. But in heat map it is able to maintain the sequence that we have passed. So if you see the sequential coloring over here, white means +1, that is strong correlation. Black means -0.4, I guess, as per the scale. So still inverse correlation. And if it is around, if it is purple, that means there is no correlation. So age has almost no correlation with value in euros, and age has inverse correlation with potential. That's why it is appearing in black. So that's how you can interpret your heat map. So that's it for this video. We discussed all 12 graphs so far. So in this particular, just to wind up, we discussed 12 plots are graph, starting from pair plot, line plot, disk plot, joint plot, then KDE, kernel density, then scatter plot, bar plot, cluster map, box plot, violin plot, regression plot, and lastly heat map. And if you are interested, I have also created a video for matplotlib, which is already present in the playlist. You can refer to that. And the next notebook I'll be working on will be of Plotly. So till then, take care, and I'll see you in the next video. Thanks.